Hey guys, from calculus, this is 4.1. We are starting antiderivatives. So an antiderivative is the inverse operation of a derivative. So back when you were learning in algebra how to solve for x, if you had a plus 3, in order to undo it, you would subtract 3. Well, just like addition and subtraction are inverse operations, so are derivatives and antiderivatives. Okay, so we are just undoing a derivative. So let's just look at the power rule. Whenever we had x raised to a number, power rule, we would first multiply, right? And then subtract 1. We're here, if we're doing the antiderivative, we're going to do not only the opposite operations, the inverse operations, we're going to do them in the inverse order. Okay, so we're going to add 1, and then we're going to divide by that new exponent, which is n plus 1. Okay, so let's brainstorm a second and see what that looks like with some numbers. Okay, if I want to do the derivative of x to the fourth, I multiply that 4 to the front, right, and subtract 1 from the exponent. So I get 4x cubed. So let's look at this different equation. Now we have one, expression with a plus 3. So if I do the derivative, I get 4x cubed plus derivative of 3 would be 0. So I end up with the same answer as the last question, even though it looks very different without doing the derivative. Let's look at the next one. If I do the derivative, I get 4x cubed, and then derivative of a negative 5 is 0. So notice that I can do the derivative of 3 different expressions and get the same exact answer. So the question you should be asking yourself is, well, when I'm going to undo, and if I go to do the antiderivative of 4x cubed to get back to x to the fourth, how do I differentiate the fact that here there's no constant, here's a constant of plus 3, and here a constant of minus 5. Okay, so we're going to look over here at this right side. It says because the derivative of a constant is 0, we must assume that there could have been a constant when we're solving the antiderivative. Okay, therefore, every time we do an antiderivative, we work backwards. We're going to include a plus c in our answer to represent that constant that could have been there. So for example, if I do the antiderivative here, I know I'm going to get x to the fourth, but I'm going to add a plus c. Even if that c is 0, that constant is 0, then it still represents this answer. My constant could be a positive 3 or negative 5. So for now, leaving our answer with a plus c is called a general solution. Towards the end of this lesson, we're going to know how to get to a particular solution and actually be able to solve for that constant c. Okay? So let's try these here. Find the antiderivative. If my derivative was 4x cubed, that's the one we just did, the antiderivative must be, well, I'm going to add 1 to the exponent. It's going to be x to the 4. And then if I divide by my new exponent, 4 divided by 4 is 1, so I can leave it as x to the fourth. And then I have to include that plus c. Okay? So then it gets you thinking, what would the antiderivative of 0 be? Okay? Remember, if constants disappear to 0, then a 0 must have been a constant. We're thinking backwards now. Okay? Let's think here. If I did the derivative of something and it gave me 2, what must that function have been? Well, I always land with just a constant when I had a number times a variable, right? So if I'm working backwards, this must have been a 2x, derivative of 2x is 2, and then plus the possibility of some constant having been there. So just like in derivatives that we go with one term at a time, we're going to do the same thing with antiderivatives. So the antiderivative of 4x cubed, we've seen this one a few times now. We know it would have been x to the fourth plus, what do you think gives me the derivative of 2x? So if I do the derivative of something and it gives me 2x, it must have been x squared because the derivative of x squared is 2x. And then again, don't forget that plus c. We always have to assume that there could have been a constant. Let's see one more of these. The derivative would have given me cosine, so what was my original function? Well, if I think back to my derivative rules of trig functions, I know that the derivative of sine is cosine. Therefore, the antiderivative of cosine must be sine. And again, don't forget that plus c. All right, So the general statement of an antiderivative, we use this symbol here that's called an integral, okay? Now these are called indefinite integrals because I'm just working my way back to the function. Remember we said that the whole concept of an integral is to end up getting the numerical area under a curve. That will be called the definite integral. Indefinite is just working our way back to the equation, okay? So this is step one. This is our general solution. This symbol is an integral, means to do the integral of f prime, which would just be f, and then don't forget that plus c. You always need that plus c, okay? I can't tell you how many AP students lose points for forgetting that plus c. So some notation that you're going to be seeing, y prime, f prime, u prime, or dy dx, okay? So let's go over the main 12 rules. The antiderivative of 0 is a constant. The antiderivative of a number is that number x plus a constant. Here is that reverse power rule that we already saw. Whenever you're working with multiple terms, you just solve one term at a time. Okay, again, terms are separated by addition or subtraction. E to the u, remember, is just e to the u plus that constant. The antiderivative of u prime over u, it's just working our way backwards to ln of u. The answer here does include an absolute value bar. That is something new. And if you think your way backwards, if my function was ln of u, the derivative would be u prime over u. And then we have our 6 trig functions working backwards. The antiderivative of sine is a negative cosine plus c. Antiderivative of cosine is a positive sine plus c. Antiderivative of secant squared is tangent plus c. Antiderivative of cosecant squared is negative cotangent plus c. Antiderivative of secant tangent is secant plus c. And antiderivative of cosecant cotangent is negative cosecant plus c. So these are pretty easy to remember if you've already memorized your derivatives. If you're in my class, know this like the back of your hand. I will tell you that the trig functions start to get tricky in remembering who gets the negative, okay? We remember that in derivatives, we told ourselves that if the function had a c, the answer gets a negative. Well, here it's reverse. Again, this is an inverse operation, so the rule is inverse. Now it's if the answer has a c, right? We see here a c and here a c. If the answer has a c, it gets a negative, okay? So be very careful with that. That usually stumps up students all the time. And I wrote down that rule here so you can put in your notes. For trig derivatives, if the question has a c, the answer has a negative. For trig integrals, if the answer has a c, meaning starts with cosine, cosecant, cotangent, then the answer has a negative. So now let's practice some examples. If y prime is c, y, I have to do the antiderivative. Antiderivative of a number is that number times an x. Don't forget your plus c. Now I have a variable x. So here I'm doing reverse power rule. We can assume that this 3x is saying 3x to the first. The reverse power rule says to add 1 and divide by that new exponent. So I have 3x squared divided by 2 plus c. Okay? And you can put your x a little bigger so it's that 3 over 2 is being multiplied. I promise you, after seeing these for a while, you're going to get a lot faster. You're not going to feel the need to take all these steps. Now, in derivatives, you learned that if you had the variable in the denominator, or if you had like a radical, you would rewrite those with fractional exponents, and if you need to bring them up with negative exponents. Same applies here. So before I even start doing the antiderivative, I'm going to rewrite this as x to the negative third. Okay, now I can do that rule, the reverse power rule, of saying I'm going to add 1 to this exponent and then divide by that new exponent. Okay, so this will give me negative 3 plus 1 is negative 2, and I'm dividing by negative 2. I can write this as Remember, now this negative exponent is going to take it down because all of my answers have to have positive exponents. So negative 1 over 2x squared. And don't forget your plus c. All right. Let's look at this next one. There are 3 separate terms, so I'm going to do one at a time. Okay. Here I have 3x to the 4th. I'm going to add 1 and divide by that new exponent minus 5x squared. I'm going to add 1 and divide by that new exponent. Plus, this is an x to the 1st, so I'm going to add 1 and divide by that new exponent. Okay, so 4 plus 1 is 5, so I'm going to have 3 over 5 x to the 5th minus 2 plus 1 is 3, so I'm going to have 5 over 3 x to the 3rd plus 1 plus 1 is 2, so I'm going to have half x squared, and don't forget your plus c. All right. So now here, I told you that when we have a radical and it's in the bottom, we want to make that a fractional exponent and we want to bring it up. So I have options too. I also have 2 different terms in the numerator. Okay, so you can do a quotient rule here, which is not a rule we learn in AB. When we're in BC, we learn how to do an integration quotient rule. Okay, so I'm going to have to work on splitting this. So to start, I'm going to say x over, and instead of saying square root of x, I'm going to say x to the 1/2 plus 1 over x to the 1/2. So I split it and I wrote these as fractional exponents. Now to simplify this left one, if I have the same base, I can subtract exponents. My exponent in the numerator is 1. 1 minus 1/2 is just 1/2. And now here I don't have the same base, but I can bring this up with a negative exponent. So now I'm going to apply the rule to each term. So I have x to the 1/2. I'm going to add 1 and divide by my new exponent. Plus, my second term is x to the negative 1/2. I'm going to add 1 over my new exponent. Okay? Half plus 1 is 1.5, and we can call that 3 over 2. If you need to get a common denominator, you can call this 2 over 2. We're going to do the same thing here. Negative half plus 1 gives me a positive half. Divide by my new exponent. Okay? Now, when I divide by a fraction, remember I can multiply by its reciprocal. You guys might remember that as keep, change, flip. So the flip of 3 over 2 is 2 over 3, and I'm going to multiply that to the front. So 2 over 3, x raised to 3 over 2, plus, if I flip and multiply, I'm multiplying a 2 over 1, x to the 1/2, and I put my plus c. No need to change those exponents back into radicals. All right, let's work our way up here. I'm going to rewrite this as x to the 1/2. The antiderivative, I'm going to add 1, divide by that new exponent, and I get x raised to 3 over 2 divided by 3 over 2. Remember, keep, change, flip, and I get 2 over 3, x to 3 over 2. Don't forget your plus c. Okay, now in the same way in derivatives, when I had a coefficient, I can just bring it down. I can do the same thing here. I can just bring down that coefficient of 2, and then the antiderivative of sine is a negative cosine, and then don't forget your plus c. I personally like to put those negatives out front, so I would rewrite this as negative 2 cosine of x plus c. Okay, if f prime is x plus 2, f of x, antiderivative here, It's x to the first. I'm going to add 1 to my exponent, divide by my new exponent, plus antiderivative of a constant is that constant times the variable. I'm going to clean it before I put my plus c. I have x squared. You can put times 1/2 or you could put over 2. Two different ways of writing your answer. Plus 2x, and don't forget your plus c. All right. So now let's look at this one down here. A little trickier. We have the integral, of sine over cosine squared. Well, I'm going to try and rewrite this first as the integral of sine of x over cosine of x times cosine of x. Okay? I know that sine over cosine is the same as saying tangent. Okay? And then if I have left over a cosine in the denominator, 1 over cosine is the same as saying secant. And I do have a rule for tangent and secant, right? So I'm going to rewrite that as the integral. And with multiplication, I can switch their order. Maybe you're used to seeing it as secant tangent. And the antiderivative for secant tangent is just secant. Don't forget your plus c. So notice that every time I was rewriting, I would keep my integral. The moment I finished doing the antiderivative, then I did not need my integral or that dx anymore. Okay? That dx is part of the notation of the integral. We've talked a lot about this plus c being called the general solution. Okay, so a general solution is your answer to an antiderivative that has that plus c. Now, I told you we were going to be able to figure out how to solve for that c. Okay, so I will be giving you what's called an initial condition, meaning I will be giving you an ordered pair, an x comma y. You're going to plug that in to, let's say, here, right? You plug it into your x, you set it equal to y, and you're going to be able to solve for your c. Once you have that c, you put it right in that spot of your answer, and that is called your particular solution. Okay, so let's look at this question. Find the particular solution of f prime of x passing through 2, 4. Step 1 is going to be to get my general solution. Okay, so if this is f prime, that means f antiderivative of 3x squared. I have 3x squared. I'm going to add 1 and divide by that new exponent minus antiderivative of 1. You just add the variable, and then we say plus c. Okay, I'm going to take a quick moment to clean that. 2 plus 1 is 3. 3 divided by 3 is 1x raised to the third power minus x plus c. Okay, so there's my function nice and clean. Now, step 2, for my initial condition, I'm going to plug in that x comma y. So remember, f of x means y. So I'm going to put the 4 here, equals, and then I'm going to plug in the 2 into my x's. Okay, now I'm going to solve for that c. So I have 4 equals 2 cubed is 8 minus 2 plus c. Okay, so now here we get all right, I subtract that 6 over, and I get that my c is -2. Now, I'm not done because I asked to find the particular solution, which means I'm going to grab this antiderivative that I found, and I'm going to plug that c right back into that spot. So I can say f of x equals x cubed minus x, and instead of putting plus c, I'm going to put what c is, which is 8 -2. And that right there is my particular solution. So let's label really quick. Right here, we had our general solution. We had our c, And then now this is my particular solution. Let's see 3 more questions and then we'll close this up. So they gave us f prime is 1 over x squared. Find the particular solution that satisfies the initial condition. And here they're giving me that f of 1 is 0. That means that my ordered pair is 1, 0. So I'm going to take a moment and rewrite f prime to say x to the negative second. I'm going to do my antiderivative, so that means f of x. I'm going to add 1 to that exponent and divide by my new exponent. Negative 2 plus 1 gives me negative 1, and divided by 1, I could just put a negative right up front, and I'm going to have my plus c. There is my general solution. I can also rewrite that as negative 1 over x plus c, okay? So now, next step is going to be to plug that in. So if that's what f of x equaled, my y is 0, and then my x is a 1. All right, so I have 0 equals negative 1 plus c. Move that 1 over, and I have that c equals 1. Last step, plug that c in. I have f of x equals, here was my general solution. I'm going to say negative 1 over x, and instead of plus c, plus 1. Done with this question. That is my particular solution. Moving on to the next one. They gave me f prime of s, and it says find the particular solution if f of 3 is 2. So that's my ordered pair there, 3, 2. Okay, here is my f prime of s. So f of s, that just means that the variable inside the function is an s. So let's see if we can get a little faster at this. If my exponent is a 1, my new exponent is going to be a 2, and then I'm going to divide 10 by 2. 10 divided by 2 is 5. Minus, if my exponent was a 3, it's now going to be a 4, and 12 divided by 4 is 3. Don't forget your plus c. Now we're going to grab that ordered pair. If this is our x and our y, that means the inside is our s, so 3 is going to replace the s's, and 2 is going to be what f of s is, okay? So I'm going to say 2 equals 5 times 3 squared minus 3 times 3 to the 4th plus c, okay? So here I get 3 squared is 9, 9 times 5 is 45, minus here 3 cubed times 3, I get 243 plus c, and I'm just going to put my equals 2 over here, a little easier to see. And when we clean that up, feel free to use your calculators. You get that c is 200, okay? So over here, I had my general solution. I have my c, and now my last step is going to be to plug c into my general solution. So I have f of s equals 5s squared minus 3s to the 4th, and instead of plus c, I'm going to put plus 200, and that is my final answer. That is my particular solution. All right, for the last one, I am going to step it up a little bit. I'm giving you f double prime, okay? So in order to find our particular solution, it's not harder, it's just a little lengthier because we're going to have to do the process twice. Once to get down to f single prime, and then another time to get down to f, just f of x, sorry. So they gave us f double prime of x, okay? And here's our ordered pair for f prime and our ordered pair for f. So if I had this as f double prime, f single prime, doing the antiderivative once takes me to a negative cosine of x plus c. Next, I'm going to plug in my initial condition. Now I have two of them. I have 0, 1 and 0, 6. Notice that this one has a prime, which is why this is the one we're going to plug in here. So that means f prime equals 1 when I plug in a 0. Okay? Now, cosine of 0 is 1. 1 times a negative, I have negative 1. And I get that c equals 2. Okay? Now I'm moving on to my next step. I'm going to plug that in. So I'm going to say f single prime equals a negative cosine of x. And instead of plus c, I'm going to put plus 2. Here is my first particular solution. Okay? Now, this was my general solution just for the sake of labeling things. And now we move on. Now we're going to do the whole thing all over again. Okay? So this was our answer for our first antiderivative. Let's move on. So from here, I'm going to go from f prime to f. Okay, the antiderivative of a negative cosine, if you haven't memorized, you have memorized that the antiderivative of cosine is sine. So you can just bring down that negative. Okay, now plus the antiderivative of 2 is 2x, and now we do plus c again. So now I can use my ordered pair that goes for f because I'm down to f. So I can say that the whole thing is going to equal 6. And I have negative sine of 0 plus 2 times 0 plus c. Well, sine of 0 is 0. So I have 6 equals 0 plus 0 times anything is 0 plus c. So that means that c is 6. Okay? And over here we had our other general solution. So now for my final answer, all I'm going to do is I'm going to rewrite that one. So f of x equals negative sine of x plus 2x. And instead of plus c, I'm going to put plus 6. And I have made it down to my final answer, the particular solution.